Okay. So now, as earlier on we talked about, so what word embedding is trying to do is that it's trying to figure out how we can represent words, right, in a vector form such that two vectors close to each other represent two similar words. Okay. So for instance, if you have a vector like maybe 0.775, right, and then another vector like say 0.78, okay, and this vector represents say man, and this one represents say let's say woman. Okay, so this vector is, you see 0.775 is very close to 0.78. Okay, and they should represent something that are very close. All right, something that are very close. Okay, let's take a scenario here to further understand. All right, so we have this representations over here where we have some text over here. So we have queen, man, woman, dog, cat, kitten, king. You can keep on adding maybe house or something like that. Okay, and then here we have say features, right? Based on these features are the ones that, remember here we based on features like this, right? And then we're saying that go through the features and then predict, so something like that. So here we have features like gender, royalty, age, something like this. Okay, so we can base on these features, right, and then see which or and then generate these kind of word embeddings. Okay, word embeddings for each of the text over here, right? Now initially this is what we used to do, right? What we have learned so far, right? We have maybe we have some text. Okay, we have some text, some huge text over there, right, which is nothing but our corpus. Okay, so let's say this is 1000. This text contains say 1000 words. Okay, and then in this 1000 words, let's say we have the word queen in there. Okay, let's say we have the word queen in there, and then we have these ones. We have all the other text over there, right? Now, let's say this queen, if we convert it to, we remember that we're going to, in order to work with this, we need to tokenize it. Okay, we need to tokenize it. And then once you tokenize it, you're going to have all the words. So maybe there will be on its own, is will be on its own, man will be on its own, maybe going will be on its own, something like that. Okay, and then all these are going to have their index. So this will be index 0, index 1, index 2, index 3, index 4, index 5, all the way to index 1000, right? Or if it's 10,000, let's say, I mean, depending on the number of words that are there. Okay, so all of them are going to have their index. Now, if you want to pick, say, queen, right? You want to pick queen and see and form one hot encoding for that, right? Let's say queen appeared at index, say, index 300. Okay, that's where the word queen appeared. Okay, at index 300, that's where the word queen appeared. So in that case, you're going to have 0, 0, 0, 0, 0, all the way to you reach index 300. Okay, and that's where you're going to have 1. Okay, and then it will continue 0, 0, 0, 0, 0, 0 to it reaches 1000. Okay, it reaches 1000. So that's just for queen. Okay, that's how queen is going to be. The matrix for queen is going to be, and then the matrix for all the other ones. So if you pick there, right, there is going to have, that's the first word, so maybe that's gonna have 1 over there, and then the rest, right, the rest is gonna be 0, 0, 0 all the way to 1000, right, or 999 over there. The same thing for if you pick man, right, it's gonna have wherever, let's say man appeared at say at index say 400, right, index 400, so you're gonna have 0, 0, 0, 0, 0, 0, 0, 0, 0, so you reach at index 400, then you put 1 over there. The rest is just gonna continue 0, 0, 0, 0 till you reach 1000. Okay, like that. All right, so I mean, you see how sparse it's gonna be. A lot of zeros with just few ones in there. Okay, and it's going to be difficult to establish relationship between say man and maybe if you have a woman, let's say woman appeared at 700, and so you're gonna have 0, 0, 0, 0, so you reach at index 700. Okay, and then you put 1 over there. Right, and then 0, 0 will continue like that. So if you want to establish a relationship between man and then woman, it's going to be very, very difficult for you to do that, right? Because this one is having its own sparse matrix, this is having its own sparse matrix. Okay, so that becomes a challenge over there. All right, now what we're trying to do is that we want to convert everything in a form of in matrix like this, right? Embeddings like this. Now let's see how this matrix actually is generated. So we have features over here. So based on this feature, is how we are, generating these numbers in here. Okay, these are random numbers that I've put over here. But when we go to the lab session, we have tools that we're going to use to give us the accurate ones. Okay, so this one is just for your understanding over here. So for instance, we have gender over here, right? We can relate gender to man, right, and then woman. Okay, man and woman. We can have gender. Cat, dog, cat, and then kitten here, right? They are less related to gender. Okay, they are less related to gender, right? You can also relate queen and then king to gender. Okay, because queen represent women, right, and then king represent man. Okay, so or female and then male. Okay, so in that case, if you pick say royalty is more. You can represent it with queen and then king. Okay, more of that. As against if you pick royalty and say dog and cat, they don't really match. Right, so you see that the vector over here is very, very low. Okay, this one is not even having that. Okay, but if you see the values for this, for king is very high, for king is also very high. Okay, and then for man, woman, it can be 50-50, right? A man can be a king, right? A man can be a king, right? And then a woman can be a queen. All right, so they have some kind of relationship over there, right? But it's not that much. It's not that once you're a man, you're going to be a king, or once you're a woman, you're going to be a queen, right? But if you're a queen, you're a queen, right? So that's going to be, you're much related to royalty. Okay, you're much related to royalty. So if you're a man, you can be related to royalty or not. Okay, so it's just a 50-50 kind of thing. All right, and then if you pick say age, right? A queen can have an age and so on and so forth, right? So all this will be filled, right? All these things will be generated when we go to, we have Keras. In Keras, we have Keras embeddings, which is already built in Keras, which we are going to use, all right? But you have to get the understanding, all right? So that is basically how these things are done, okay? So based on these features, we will be able to generate this kind of features, okay? So we call it feature representation. Okay, so we call it feature representation, meaning that we are representing these features in terms of these kind of embeddings or metrics. Okay, so this kind of metrics that we're going to generate is what is referred to as the embeddings. Okay, so the word has been embedded, right? It has been embedded in this. Okay, so for instance, queen has been embedded in this, woman has been embedded in this, something like that. So this one that we are going to generate is what is referred to as word embedding. Okay, so this queen can appear at, as I said, maybe index 300, right? Index 300. This can appear at index maybe 700, something like that. But it really will not matter that much, because we're going to have the embeddings, which is going to base on the embeddings, right? And then establish that kind of relationship. All right, so let me even clear this, and then okay. So remember in the one hot encoding, right, you're going to have a very high dimension, okay? But in this case, depending on the number of features, right, basically the features are not going to be very high, okay? The features are not going to be that much high, right? Let me clear. The features are not going to be that much high, maybe about 300 features or something like that, okay? It's not going to be, that much high, unless you're working on a very huge industry project, right, where you're going to have very huge data set. That's when it's possible to have a higher dimension like that, okay? But ideally, your dimensions are not going to be very, very high, all right? So in this case, for queen, right, the queen will be based on these features, right? And then you have these kind of embeddings. So the queen alone will be having 300 different, values in there, which is going to represent the embedding for the queen. Okay, and the same thing for the man is going to have these kind of things, right, all the way to the 300, right, depending on the number of features, right, different values. Okay, different values. So at the end of the day, you're going to see where queen actually relates. Okay, so if the word is gender, it's likely to predict the next word depending on the values that are there. Okay, so if I have queen in a sentence, right, I would be likely to predict the next one, right, if I pick these two embeddings. Okay, so the embedding for king and embedding for queen, okay, I'll be able to predict each other, okay, based on the sentences. So if I have one sentence like maybe this man is holding a royal title. Okay, this is the sentence. This is the first one. And then I come and say that he is a Okay, that is this. Okay, he is a. Now, if I leave this thing and I say that my NLP model should predict the next word over here, okay, it's likely that once royal here, royal is here, it's going to predict either king or queen. Okay, it's possible, right? And since he is closer to king, right, than queen, it's going to predict king over here for me. Okay, because royal is very close to king or queen, right? So if you base on royal, it's possible to predict either king or queen. But since he is also close to king than queen, is now going to finally predict king over here. Okay, for me. All right, so that's basically all that we try to do in word embeddings. Okay, that's what we try to do in word embeddings. All right, so one thing that you need to also note is that whilst we are doing the word embeddings, we will end up having low dimension, right? Low dimension and dense, D-E-N-S-E. Okay, so low, L-O-W, right? And then dimension, right? D-I-M-E-N-S-I-O-N, right? Low dimension and then dense matrix. Okay, something like that. That's what we will be having, right? But if we are using the one hot encoding, we're going to have, right? We're going to have maybe 0, 0, 0, 0, 0, 0, and then maybe the word is appearing at maybe at say 900 or index 900. So that's only the place we have one over there, and the rest will be 0, 0. So in this case, we're going to have high dimension. Here we'll be having high dimension, right? And then sparse matrix, sparse, S-P-A-R-S-E, right? Sparse matrix. Okay, that's basically what we're going to have. So we're going to have a high dimension with sparse matrix if you're using one hot, but if you're using the word embedding, you're going to have low dimension with dense matrix. Okay, so what we are trying to do is to move from this sparse matrix to dense matrix, and that's when word embeddings come to place. Okay, that's when we consider word embedding. Now, if later on you convert this thing to a two-dimensional space, right? So let me get rid of this one here. If you convert this thing to a two-dimensional space, you will realize that things like say cat and then kitten will be closer to each other, right? And then dog, right, will also be closer to each other as compared to say maybe dog and then house, or maybe cat and house or something, right? Since kitten is just a baby cat, you see that it will be very, very much close to each other, right? And then both of them will be closer to dog as well, right? Man will be very close to woman, right? And then king will be very close to queen, right? If you convert this into a two-dimensional space, you will see that you come up with something like this. Okay, you realize something like that. Okay, and that's basically what word embedding is all about. Okay, word embedding is all about. Now we're going to consider the two strategies that we use to do these kind of things, which is word-to-vec and glove model. Okay, so we're going to see that one in the upcoming session as well. All right.